Bone. An amazing physiological combination of unique properties. It is rigid yet flexible, lightweight, yet sturdy enough to support the body. From the time of Hippocrates, bone has been known for its potential for regeneration and repair. It is this extraordinary regenerative ability that has led doctors and researchers alike to study its properties, all in an effort to improve and accelerate bone healing. As early as 1889, surgeon Nicholas Sen reported using demineralized bone as a vehicle for the delivery of antiseptics in the treatment of osteomyelitis and certain bone deformities. In 1945, Pierre Lacroix proposed that a hypothetical substance in bone was responsible for initiating bone growth. But it was not until 1965 that Dr. Marshall Urist discovered proteins trapped within the bone matrix were responsible for initiating new bone formation. He coined this phenomena autoinduction, now known as osteoinduction, and named these proteins bone morphogenic proteins. Today, research into bone regeneration and repair is alive and well. With continuous and exciting advances, LifeNet Health is proud to be a leader in this research, with more than 40 patents and technological advances like PAD that maximizes osteoinductivity in demineralized bone graft products. Bone formation and remodeling is a continuous physiological process which involves a structural matrix, specific biological stimulants, and stem cells. Physiologically, new bone is induced to form when osteoclasts, cells that demineralize or remove the minerals that make up the bone matrix, remove enough of the matrix to expose the bone morphogenic proteins and other bone growth promoting growth factors. Bone morphogenic proteins trapped within the matrix are capable of inducing stem cells to differentiate into osteoblasts, cells responsible for new bone formation. Since bone morphogenic proteins induce stem cells to differentiate into bone-forming cells, they are referred to as osteoinductive. Today, technological advances make it possible to reproduce the body's natural demineralization process, allowing for the creation of osteoinductive medical products. The percent of the mineralized matrix left intact after demineralization is fundamental to achieving optimal osteoinduction. When the bone matrix is over-demineralized, acid used during the process denatures or removes the growth factors trapped within it. This results in lower levels of active growth factors and proteins, and therefore lower osteoinductive potential. If tissue is under-demineralized, growth factors trapped within the matrix are not fully exposed, and as such, are less capable of interacting with surrounding cells to rapidly initiate bone formation. Here, we see under-demineralized bone. This section reveals an abundance of intact matrix, trapping the growth factors beneath. If the growth factors are not unearthed, so to speak, they cannot effectively influence new bone growth. Tissue that is optimally demineralized has an ideal level of residual calcium. This allows for the proper exposure of growth factors and proteins, resulting in optimal osteoinductivity. Published studies have shown restricting demineralization to residual calcium levels between 1 to 4% is necessary to achieve optimal osteoinduction. LifeNet Health holds the patent and proprietary process for tissue demineralization to achieve a residual calcium of 1 to 4%. Therefore, this product is only available from LifeNet Health. To initiate the PAD process, a technician enters the appropriate weight and other associated donor information. Through a proprietary algorithm and nomogram, the PAD system will take care of the rest. Within the chamber, acid is first pulsed into the bone. The acid penetrates the bone matrix, replicating the normal physiological process of the osteoclast eating away the minerals. Immediately following this acid bath, a buffer solution is introduced via computer-controlled steps. The acid bath buffer sequence continues until the bony wall of minerals is removed, exposing the growth factors beneath. A nomogram calculates the appropriate demineralization level based on the donor bone weight and density. Using this careful computer control, the finished product conforms to a targeted residual calcium level between 1% and 4%. PAD, the future of Allegraft Bio-Implant Demineralization.